Hello and good morning to all of you. Okay, this is Vijayam Physics classes. Okay, this is Vijayam Physics classes and myself I am Siraj Kumar. How are you all? Okay, after a long time gap I came back to the live class. Okay, because my school started and means I have to go to college, so that's why a little bit adjustment problem. Okay, so but see, remember, see, today onwards I will be having this regular classes. Means every Sunday we will be having class. Okay, this Sunday I am going to teach optical instruments, and in the next class I am going to discuss the gravitation. Okay, the gravitation I will be discussing in two parts. In the gravitation, the part one will be like we'll be discussing about the Newton's universal law of gravitation, and then acceleration due to gravity and the gravitation potential energy. Okay, those things we'll discuss. That is in the part one. And in the part two, we are going to discuss about the Kepler's laws and the problems based on the Kepler's planetary motion and the satellites. Okay, all those things we'll be discussing in the part two of that gravitation. So means here, okay, even though it will take certain time, but please kindly adjust with me because the time problem. Okay, so based on the time problem, I am making like this. Okay. Okay, now see carefully. So today what we are going to discuss. So today we are going to discuss about the optical instruments. Okay, see carefully. This is actually the continuation of the ray optics part what we discussed here. See, in the ray optics here, what we discussed here, we means here I explained about the ray optics, the reflection of light, the refraction of light, the lenses, prism, and the dispersion of light. So those are the main basic concepts I discussed there. Okay, in today's class, what I am going to discuss, I am going to discuss about eye, and also see here I am going to discuss about its defects, the eye and its defects, and then I am going to discuss about what is called the simple microscope, compound microscope, and the telescopes. So there are two types of telescopes are there. Those two types of telescopes I am going to discuss. Okay, the first one will be like it is called as astronomical telescope, and then it will be like a terrestrial telescopes. But see, once if you got an idea of the eye and the simple microscope, the entire optical instruments will be in your hands. Okay, and see, remember this is the one definite means a possibility of different question will be there. So one must prepare this topic also for IIT as well as for the NEET, mains and advanced also. Okay, see here, this is a very, very important one. Okay, I think you are all following me. Okay, see carefully, let us start our class. See, let us start our class with a topic called eye. See, what is the eye here? See, actually, see, I can see the things, you can see the things, we all can see the things because of the eye. The eye is the basic and fundamental part, okay, which is responsible for us to see the objects, okay, which is fundamental to see the objects clearly. Okay, see carefully here, if you look at the eye here, see what does the eye consists of? See what are the main parts of the eye? See, just look at the structure of the eye. Okay, see, actually, see, eye don't see anything. Please remember this. This is very, very important. See, eye doesn't see anything. Then who is observing? Okay, who is observing? See, actually, our mind is observing. See, eye is just a window. See, what is the eye here? Eye is just a window which will allow the light signals to enter into our brain. So, brain is watching everything. Okay, please remember that one. See, our brain is watching everything. So then what the eye is doing here? Eye is just a window which is just allowing the light to pass through it. So if you close your eyes, you cannot see anything. Why? Because no light is entering into our system, our brain system. Okay, see, nothing is entering into our brain at all. So that's why you cannot see anything. Okay, so that's why here the eye is an important part because it is allowing the light to pass through it. Okay, see here, if you see carefully, what does an eye consist of? See, the eye may basically consist of, this is called as cornea. The outer part of the eye is called as cornea. Okay, see the cornea consists of, see at a certain distance, see it is having a, okay, let me draw the structure. Okay, this is the structure of the eye. Okay, see this is called an optic nerve. See this is called an optic nerve. See the optic nerve is the one which will send the signals to the brain. Okay, see this outer part of the eye, see that one we can call it as a cornea. See this is a transparent fluid here, okay, which will allow the light to pass through it. Means you see why the cornea is, so it will just protect the eye. And see here we will have this is called as the lens part. See it is having a lens here, so this is called an optic lens. So this is the lens part here. So apart from this one, see carefully here, it will having a ciliary muscles. So here it will have a ciliary muscles. Okay, ciliary muscles. Okay, see here these ciliary muscles, what they do? Okay, they help in contraction and expansion of the focal length of the eye. See, okay, that process is known as the accommodation. Okay, that we'll discuss later. Okay, see this is the ciliary muscles, and then see carefully here in the middle. See, apart from that, see we are also having iris. See at this point we are having iris. Okay, and see in the middle we have the pupil. We have the pupil, and see here what we have the retina. See the retina is like a screen on which, see the retina is like a screen here on which the image will form. Remember, see the image formed is inverted image. Okay, the image formed is nothing but an inverted image. Okay, just a second. Okay. See, remember, see here the image formed is what here? The image formed is the inverted image. Okay. See, the inverted images are always real images. Means I say whatever I am seeing is that is real. But see carefully here, see even though the image formed on the retina is inverted, but see your brain will see in an erect position only. See our brain, what it is seeing. Our brain is the one which is observing everything. Okay, see the optical signals will pass to this optic nerve. See suppose, see for example, if you are exposed to more radiation, or suppose if any accident occurs, if optic nerve breaks, then they will become permanent blind. Remember, in the whole universe, there are only 1% or 2% are permanently blind. But see, remaining 98% of the blind people, they can be cured. Okay, they can be rectified also. See, that's why they'll say, see the organ donation, like eye donation. See, why they say eye donation? Because, see, they can be fit to some people who need these lens part and all, or who need the parts of the eye. Means the only part of the eye is nothing but the lens, which you can replace, which you can put. But if the optic nerve is not there, no one can do anything. Okay, but nowadays see the technology has improved a lot. Maybe they may keep the artificial eyes also in future. Okay, maybe if you become a scientist, please try to keep that one so that we can remove the blindness entirely through the universe. So the eye is a very, very important, because see, through eyes I can see all the things and you can see all the things. If the eyes are not there, the whole universe, it will appear to you like a dark color. Okay, so eye is an important point, so you need to protect it very carefully. Okay, anyhow, see carefully here. So see here, what are the main parts of the eye we got here? The optic nerve, which will carry the optical signals to the brain, and then the retina, where the images are formed. The ciliary muscles are those which will change the focal length of the eye. In the change of the focal length of the eye means what you see, sometimes you will see the nearby objects. Sometimes you need to see the very far off objects. So based on that one, your eye has to adjust its focal length. So that's a natural focal length. See that there's a natural phenomena. Okay, that is possible through ciliary muscles. Okay, then we have here this cornea, the outer part of the eye, which will protect the eye. And then see we have the pupil and iris. See, these are very, very important points. See, what is this iris here? See, iris is nothing but it's an opening of the eye through which the light will pass. But see carefully, the iris, see what it will do, the iris controls pupil. So pupil is like a hole. See the black spot, the black color one, what you are seeing there, that is a pupil. See, through the pupil here, what will happen? The light rays will travel. See, the pupil size will change. The pupil size will vary. That's because of the iris. The iris controls pupil. Okay, the iris controls pupil here. Okay, see here, see what will happen, see that. See, for example, they'll say, please don't see the solar eclipse directly. Why they'll say solar eclipse, do not see directly? See, remember, there's a scientific reason is there. See, it is not a blind belief. It is not what is that is called the social stigma. It is not a social stigma. Please remember, don't see the solar eclipse directly or any eclipse directly. Why? Why? Because see carefully. See, the iris controls pupil. The pupil size always varies according to the brightness. See, suppose for example, if it is more bright, suppose if it is more bright, then see what will happen? The pupil will be small one. If it is less bright, then the pupil size will increase. See carefully, if it is more bright, then what will happen? The more bright it is, then what will happen? The pupil size will be smaller, so that to allow the less light to enter, so that to protect the eye. Suppose if the pupil is, suppose for example, if the pupil is bigger one, then see what will happen? More light will enter. Suppose see during dark time, okay, during the suppose if it is a dark, then the pupil size will increase. See here carefully here, during the solar eclipse. See here, you have a sunlight here. See, when you have a sunlight here, see carefully, during the solar eclipse time, the light is stopped for a minute. When the light is stopped, then what will happen? Your pupil size will increase. Okay, then suddenly what will happen? The screen means the moon will move away, the more light will enter. Okay, see, during solar eclipse time, during eclipse time, it will be darker, so your pupil size will increase. Then say suddenly the moon will move away, so more light will enter. So more light will enter into your eyes, so it will cause damage to the eye. See, do you know? Because of the solar eclipse, see, many people got blinded. Okay, they thought that okay, they are saying for the fun. Okay, it is nothing trash. Like that, they went out. They have seen the solar eclipse. They became blind. See, that's because of this reason. This is a scientific reason. It is not a social stigma, or it is not any disbelief. So are you following what I am saying? It is not a disbelief at all. Okay, see, it is a true fact here. Okay, anyhow, see carefully. The iris here, what the iris is doing here? The iris is controlling the pupil size, the size of the pupil. Okay, then see, look at another one here. On the retina, I said. Okay, then see carefully, if you look at the lens here. See carefully, in the lens here we have two types of cells. See, one is called as rods. Okay, and the other one is called as cones. See here, this is called as this is cellular lens. Means it is entirely made up of cells only. It is not any glass. See, glass what we get, that is in laboratory. Okay, see, remember, if I take a lens here, see, the lens consists of what here? The lens consists of the rods and cones. So rods are used for what here? The rods are used to denote the brightness of the light. See, the brightness of the light is means the cone, the rods part of the eye, okay, will be sensitive to the brightness of the light. And check here, the cones of the lens are sensitive to what? The color of the light. Okay, see, for example, if you look at the animals, see, the animals are having more number of rods than cones. See, the animals have more number of rods than cones. For example, if you look at the cat, see, a cat consists of more number of rods here. See, as they have more number of rods here, then what will happen? what will happen? See, they can see even in the dark also. And see, carefully, they have less number of cones, so that's why here what will happen? They cannot see the colors clearly. So, for example, see, they'll say in the bullfight they'll show the red color and they'll wrap the red color. They'll say that okay, red color is there, the animal will attack. No, that's a wrong statement. That's a wrong statement. See, why it is a wrong statement? Because see what is this one? See, the animals cannot see the colors. Why the animals cannot see colors? See, because they have more number of rods than cones. See, as they have cones are less in number, they cannot see the colors clearly. Okay, instead of that, see, the animal get irritated because of they'll push, what is that one? Okay, they'll press with that iron rods, or they'll beat it. So that's why they get irritated and they'll attack. Not because of red color. Okay, please remember that. Okay, now see carefully, the lens part consists of what? The lens consists of cones and the rods. Okay, the rods are useful for brightness of the light. They are sensitive to the brightness of the light. And the cones are sensitive to the color of the light. Okay, so this is about the eye. But see carefully, if you look at this eye carefully, see the eyes are having two types of defects basically. See what are those two types of defects? Okay. Okay, see carefully here, the defects of the eye. Okay, see the second one. Sorry. Okay, see the second one here. What is this one? This is called the defects of the eye. Okay, defects of the eye. See, what are the defects of the eye? See, there are basically two, okay, there are many defects are there. See, for examination point of view, we should discuss basically about the two defects of the eye. Okay, see carefully, what is the first defect of the eye? It is nothing but, it is called a myopia. Okay, see, what do you mean by myopia? Okay, see, myopia means what here? It is nothing but the short-sightedness. Okay, see, myopia or the short-sightedness. Okay, see what do you mean by myopia? One second. Okay. Yes, Umesh Chandra, good morning. Yes, Vijaya, good morning. Yes, MS sir, good morning. Okay, now see carefully. See what is this myopia or short-sightedness? Okay, see myopia means what here? Myopia is nothing but, see myopia is nothing but it's a short-sightedness. Means what here? The persons can see the nearby objects clearly, but see they cannot see the far-off objects clearly. Okay, see carefully. See what do you mean by myopia or short-sightedness? See the persons can see the nearby objects very clearly. Okay, but cannot see the far-off objects clearly. See that is called as myopia. Okay, see are you following what I am saying here? Okay, see that is called a myopia. See why the myopia occurs? See the myopia occurs because of see the extension of the eye lens. Dheerajeshwar, good morning. Okay, I did not see the chart clearly here. Okay, good morning. Okay, see carefully. See if you look at this myopia here, see myopia means what here? It's a short-sightedness. See why the myopia occurs? Because the extension of the eye lens. See extension of the eye lens means what here? More the focal length. See because of that here what will happen? See that suppose if you look at the structure of the eye here, see actually where the image should form here, the image should form on the retina. But see carefully, in this case here what will happen? Suppose if you look at the eye, see let us say this is the eye, this is the lens here. Okay, see regarding this one, see what will happen when the rays are coming from infinity, the rays will fall before retina. Okay, see here what will happen here, the rays will fall before retina. See that's the main problem with myopia. That's why the person cannot see the objects clearly. He can see the nearby objects very clearly. But see he cannot see the far off objects clearly. Okay, then see carefully, then here what we'll do? Here we'll keep one concave lens. See what is the lens to be arranged here? To avoid this defect, we will be keeping the concave lens. See, when you keep the concave lens, then what will happen? See, the rays, okay, will diverge a little so that they will form the final image on the retina. Okay, so that the final image forms on the retina. So that is what the arrangement they do here. See here, once again, see carefully here. See, what do you mean by myopia here? Myopia means the short-sightedness. Means the person can see nearby objects clearly, but he cannot see the far-off objects clearly. Okay, so why the defect will occur? Because of the extension of the focal length. The focal length will increase. Okay, next thing is what here? And see, okay, how you can say that you cannot see clearly the objects? Because the rays coming from infinity, they are forming before retina. They are forming before retina, he cannot see the objects clearly. Then say, what is the rectification for this one? It is nothing but a concave lens. If I use a suitable concave lens, then I can rectify it. Okay, see, I think I should say another important one. This is called as the least distance of distinct vision. Least distance of distinct vision. Okay, see, what do you mean by least distance of distinct vision? Means here, the least distance of distinct vision means, see, our eyes can see clearly the objects at a particular distance. Means suppose if you keep the object here, you cannot see that object. See, means the minimum distance must be there before your eye and the object. Then what must be the minimum distance so that you can see the objects clearly? See that distance we can call it as the least distance of distinct vision. That is nothing but 25 centimeter. Okay, see, if the object is at a distance of 25 centimeters, we can see the objects clearly. Then here up to where you can see this is the minimum distance. This is the minimum distance. See, tell me, what is the maximum distance up to which you can see? The maximum distance you can see is up to infinity. Okay, we can see the stars, we can see beyond stars also. Okay, just by looking at a naked eye. Means without direct eye, without using telescope, you can see the stars. You are seeing stars, you are seeing the phenomenon, what is happening in the universe. Means just by seeing outside. See, that is possible. That is possible without direct eye only. But see, you wanted to see the objects clearly and you wanted to see the objects nearly, or means very in a extended manner, then in that case we are using the optical instruments. Okay, see carefully, and one more important point. See, suppose for example, see, let us say this is your eye. Okay, this is your eye. Okay, see, suppose let us say the object is at a distance d. At a distance d. See, you are seeing this object. See, when you are seeing this object, you see this angle, we can call it as theta is known as the visual angle. Okay, this is called a visual angle. See, this is h naught, height of the object. See, what is the theta value here? Theta naught equal to h naught by d. Okay, so means here the theta value is inversely proportional to the least distance of distinct vision here, or the distance where the object is placed here. See, for example, you place the object at a far off distance, at a very far off distance. Means you see that time, let us call it theta 1. See, let us place it at theta 1. Then see here, what can be the angle that time? Suppose this is your eye. Okay, you are trying to see the object at a far off distance. This one is the alpha, let us say. See, definitely the alpha value is less than the theta 1. Why the alpha value is less than theta 1 here? Why? Because see, the distance increased here. See, the distance is x, let us say. This is h naught. See, alpha value is h naught by x here. See, the x value is greater than d. The x value is greater than d. So, what happens to the visual angle here? The visual angle, see, alpha value is less than theta 1. That is what I am saying. Okay, see, are you following? See, the visual angle basically depends upon what? This depends upon where the object is placed here. If the object is very, very far, then say you need a small visual angle. If the object is very, very nearby, you need a bigger visual angle. So if it is less than 25 centimeter, then you cannot see that object because it cannot form an image in your eyes. Okay, are you following what I am saying here? Okay, good. Okay, say, okay, let us come back to this myopia. See, when you come back to this myopia, see, myopia is a short-sightedness. Okay, this one I should say at the first. I did not say it, so that's why I said no. Okay, now see, once you look at this myopia, see, regarding myopia here, what we got here, we got the short-sightedness. Then see how to solve the problems related to it. See, whenever see they ask any problem related to myopia, the lens required is what here? It required is concave. And whenever they'll ask in regarding myopia, see there will be minimum distance will be there up to where the person can see clearly. Where he can see the nearby objects clearly. So that's why the U value they'll give in the problem. In the problem solving technique I am saying. See the U value they'll give. But see here, the U value is always infinity. And the V value is what up to where he can see, that is the myopic person's V value. Okay, see, are you understanding it? See carefully here. See, whenever they'll give any problem regarding this, please always take regarding myopia, see how to solve a problem. See, always take the U value as infinity. Okay, and see the V value is the value what they'll give. But remember that is negative because see before lens only the image will form. Okay, then see you have to calculate the focal length of that. Okay, see for example, see take one problem here. Okay, please try. Okay, see a myopic person can see up to 40 centimeter. Okay, that is his near point. Then find focal length of the lens needed, okay, to rectify the defect. Come on, try this one. Try this problem. See a myopic person can see up to 40 centimeter. Then find focal length of the lens needed to rectify the defect. Come and see how to do this one. Please try this one. Okay. You can see carefully here. See, please observe it carefully here. See, whenever regarding myopia, they'll give any problem. See, regarding myopia, if they give any problem, see, first thing what you have to do is that the U value is infinity. Okay, and see here, what is the V value here? The V value is X. See, the value what they gave. Yes, focal length. Is it positive? Yes, very good, Sai Pranit. Yes, very good. Very good, Dheerajeshwar. Very good, correct. Okay, good, correct. Okay, see carefully here. Okay, see carefully here what we have to do here. See carefully. The U value is infinity. Okay, what is the V value here? The V value is minus 40 centimeter. Now say we need to calculate the focal length. Therefore, say how much will be this here? 1 by F is equals to 1 by V minus 1 by U. Therefore, say what is 1 by F here? That we have to calculate. 1 by V is minus 1 by 40. And say this one is 1 by infinity. Oh, here I am getting the minus 40. You all got plus 40. Come on, see the sign convention is very, very important here. Okay, the sign convention is very, very important here. Yes, psi nickel, very good. Okay, see, but see here, minus 40 plus 40. Okay, see carefully, the focal length is equals to minus 40 here. Okay, minus 40 centimeter. See, the focal length is minus 40 centimeter. See, minus 40 centimeter shows what? See, it shows that, see, it is a concave lens. There's another very, very important one. Yes, Nani. Yes. Oh, Nani, natural. Very good. Okay. Yes. See carefully, the focal length is how much here? It is nothing but minus 40 centimeter. Okay. Yes, there is good. See, minus 40 centimeter shows what here? It is a concave lens. Okay, are you following what I am saying? See here, what is the, see carefully once again, see regarding myopia, see how to solve a problem here. See, remember always take the U value is infinity and the V value is what the value they are given. Okay, next come to another one here, see carefully. See, let us take a hypermetropia. Okay. Okay, see, can we see here what are the next? Yes, good, Umesh Chandra, good, correct, good. Okay, so are you following what I am saying here? Okay, now see carefully. Next one is what here? The next one is the hypermetropia. Okay, the next defect is what here? Hypermetropia. Okay, hypermetropia, or we can also call it as long-sightedness. Okay, long-sightedness. Okay, see carefully, see whenever they'll give this problem, means see when you will say, okay, see when you say it is of hypermetropia. See, hypermetropia means what here? It is nothing but the long-sightedness, means that the person can see the far off objects clearly but cannot see the nearby objects. Okay, the person can see the far off objects clearly but cannot see the nearby objects clearly. Okay, see that kind of defect is called as the long-sightedness. Then tell me here why this defect will occur. This defect will occur due to the contraction of the eyeball or the contraction of the eye lens. See why the myopia occurs due to the extension of the eye lens. And see why the hypermetropia occurs due to the contraction of the eye lens. And the second thing is what here? See, if you look at this eye carefully. See, if you look at the eye carefully here. Okay, see carefully here. Suppose if the rays of light are coming from infinity, see the rays will form behind the retina. Means the image form the behind retina. Okay, yes, Vivek, good. Okay, see carefully, see why the hypermetropia occurs here. See the hypermetropia occurs because of, see the rays will form, okay, the rays will converge behind retina here. Okay, see the image forms behind retina here. And the image forms behind retina, this is called a hypermetropia. And see carefully, then see what is the correction for this one. See the correction for this one is, suppose if you keep a lens here, if you keep a convex lens, see what is the correction for this one? It's a convex lens. See when a convex lens is placed here, then see what will happen. See the rays will converge and reconverge and the image forms on the retina. Okay, the image forms on the retina. Okay, then tell me, see then how to solve a problem related to a long-sightedness. See regarding long-sightedness, see the problem can be solved by taking, see the every time the U value is always what is the value they are given, and the V value is always 25 centimeters. Okay, the V value is always what here? The V value is always the image distance whatever they give. Means sorry, it is not the least distance of distinct vision. You can see carefully, see here in this case what you will do, the U value is what here? The U value is the given value, that is nothing but okay, in a minus x. Okay. Okay then. No, not infinity, Sai Pranit, it's not infinity. Okay, see what is said is correct. Okay, you see carefully, see what is said is correct. 1 second, let me see. Okay, no, see what is said is correct. Okay, see carefully here. The U value is always taken as, okay, the U value is always taken as the least distance of distinct vision. Okay, that is correct. See, the U value is always taken as the least distance of distinct vision. Okay, sorry. Okay, and see the V value is what here? The always whatever the value they are given here. Okay, see, are you following what I am saying here? Okay, see carefully once again. See what do you mean by hypermetropia? See, hypermetropia means the long-sightedness. Means the person can see the nearby person can see the far off objects clearly and cannot see the nearby objects. See, that is called as the hypermetropia, long-sightedness. Then how to solve the problem related to it? Number 1, please take the U value as D, that is the least distance of distinct vision. And see the V value, you should take it as the X here. See both are negative here. Why both are negative here? Because see the image and the object, everything will form before the retina only. Sorry, before the lens only. Okay. And see carefully. Now see, so let us use this technique here. See, let us take another problem here. See here, let us take a hypermetric person. Okay, see a hypermyopic person can see up to, let us take it as 100 centimeter. Then find the focal length of the lens needed to rectify the defect. Okay, come on, please do this one. See, a hypermyopic person can see up to 100 centimeters. Okay, then find focal length of the lens needed to rectify the defect here. See, come on, say use this technique here. See, carefully here. Come on, please solve this one and tell me how much you got. Tell me how much you got. Okay. Okay, please try. See carefully, the U value is how much here? Minus 25 centimeters, because see D means what here? 25 centimeter. And see carefully, the V value is how much here? See the 100 centimeters minus 100 centimeter. Yes, Dheerajeshwar, good, correct. Now you got positive or negative? Yes, it is positive. Positive means what kind of lens? It's a convex lens. See, that is what we said here. 20 centimeter. So Dheerajeshwar, you got one answer. Yes. And Sai Praneeth got another answer. Okay, let me try. See, 1 by F is equals to 1 by V minus 1 by U. Okay. Say 1 by F is equals to, what is 1 by V? Is minus 1 by 100. Okay. Minus of, see 1 by U, okay, means 1 by 25. Okay. So they will say how much will be there. This is 100 minus 1 plus 4 means 3 by 100. Means what is the focal length here? It is nothing but 100 by 3 centimeter. Yes. Dheerajeshwar, you are correct. Come on, Sai Praneeth, please check your answer. Please check your answer. See, here you will get negative. One you will get negative, other you will get positive here. Hey, Umesh Chandra, again you also made small mistakes. See, check carefully. U value is minus 25. V value is also minus 100 centimeter. See, just substitute carefully. Please substitute carefully. Umesh. Yes, Sai Praneeth, you got it. Umesh, please check your answer once. So that way, what the focal length is 100 by 3 centimeter. You got the positive value. See, positive means what? It's a convex lens. Okay, it's a convex lens we can use here. Okay, means you see how to rectify hypermetropy. It is nothing but the convex lens. Okay, see, apart from this one, see, we have so many defects are there, like see, astigmatism is there. Okay, and also we have what is that is called the see, color blindness is there. Okay, there are so many others are there. Okay, see, examination point of view, we need myopia and hypermetropia. Okay, see, myopia means short-sightedness, hypermetropia means long-sightedness. Okay, see, let us come back to another one. Okay, I think you got the clarity. Yes, Umesh, good. Okay, you got the clarity. Okay, okay. So let us move on to the next one. Okay, okay. See carefully here. So here, what I discussed here. See, I just discussed about what is that is called number one. Number one, I discussed about what is an eye, and then I discussed about the defects of the eye. Okay, now I am going to discuss about the optical instruments. See, remember why we are using optical instruments. See, number one, see, to increase its size. Okay, to increase the size of the image. See carefully here, if I look at my eyes, see, if I look with my eyes directly, I can see the objects very small. So you wanted to see a bacteria. See, then I need a compound microscope or a simple microscope or a magnifying glass I need to see the bigger one. Suppose I wanted to see the moon. See, I wanted to see what the moon is made up of, what rocks are there. From Earth I wanted to see. Then how can I see? See, I use a telescope for that one. So means you see these optical instruments, what they are doing, they are helping us to see the objects, one, to increase its size, and then number two, to observe them in a closer distance. Okay, one is a magnifying one and another is a closer distance. So actually these are all done by Ewan Hawke. So Ewan Hawke is the one who just first discovered this simple microscope. Okay, then he developed the compound microscope also. Okay, so means from there this development started. Okay, anyhow, see carefully here. Let us start with a simple microscope. Okay, so the first one here, this is called as a simple microscope. Microscope. Okay, so what is a simple microscope here? A simple microscope is nothing but it's nothing but a magnifying glass. Okay, if you can understand simple microscope clearly, then you can understand all the other instruments. See carefully, in a simple microscope is what? It is nothing but a magnifying glass. Okay, consists of a convex lens. It consists of a convex lens of a focal length f. Okay, its focal length is f. Okay, then see carefully, see this is the optic center, and see let us say this one is what here? This is the principal axis. And see we have this focus point, and this is the optic center. See carefully, see regarding a magnifying glass or a simple microscope here, what we'll do, we'll arrange, see what is the principle of simple microscope. See we'll arrange the object between the focus point and the optic center. If the object is placed between the optic center and focus point, then what will happen? You will get magnified. You will get a magnified virtual erected magnified image. See carefully, suppose if I take, see here I am using only one rays to represent that one because that will be simplicity. For simplicity I am using only one ray. Actually we need two rays. See in the description box I have given the notes. In that notes I use two rays only. But here for simplicity I will be using only one ray. For simplicity, okay. See carefully here what will happen. See here the ray will not converge here. So that if you just extend it, so here you will get an image. Okay, this is the image. And remember where the image will form here. The image will form at a distance d. At a distance d. Okay, then see carefully, suppose if you just observe carefully, just try to draw like this. Okay, so this is the object size, this is the image size, this is the image, this is the object here. Okay, let us say this one is OA, this one is IB. Okay, let us say it is made some angle beta. See carefully, what is the beta here? See, beta is the angle made by the image at the eye. So here you are watching, here see from here you are watching it. Okay, you are seeing from here. Okay, see you are seeing from here. Okay, are you following what I am saying here? Okay, now see carefully, then how to get the magnification of this. See how many times I got the magnification here. But see what is the problem with simple microscope is that see simple microscope will cause eye strain. Okay, why the eyes get strained here? Because you are seeing the object directly, and that will see you need to arrange this object between the focus point and the optic center. So you need that arrangement here. So to get that arrangement, see what will happen, the eyes will get strained. Okay, to avoid that strain they invented compound microscope. Okay, that we will discuss later. Okay, first see carefully, in a simple microscope here what we got here. See what is the arrangement to be, what is the principle here? The principle is that the object to be placed between the focus point and the optic center. Okay, if you can arrange like that, then you will get erect magnified image. Say for example, see carefully here, let us see the object directly. See, you are seeing the object directly. This is the object. Okay, this is the height of the object. This is the height of the object. The same height of the object. See at a distance d. See here, what is meant by d here? D is nothing but the least distance of distinct vision. Or see simply we can say near point. So near point means what here? 25 centimeter. Far point means what here? Infinity. Usually, in general. Okay, the far point may be varies from person to person. So if he is suffering with myopia, you will have different far point. For a hypermetric person, the far point is different. But in a generally healthy fellow, suppose for me, it will be different. Why? Because I am having glasses here. So my near point and far point are different. Okay, please remember that. Okay, anyhow see carefully. Suppose if I am seeing it directly, let us say I made an angle alpha. Say what is this alpha here? What is this alpha here? When the object is seen directly, that is alpha. Okay, let us call it this one is some C and some let us say some K. This is CK. Okay, this one is some L. Okay, so are you following what I am saying here? Okay, see here what I am trying to say is that, see, suppose I wanted to calculate the tan alpha. See, tan alpha is equals to alpha, means how much will be this? Say H naught by D, can I write? See, tan alpha is equal to opposite side by adjacent side. And say, remember, these are all very, very small angles. These are all marginal rays. These are all paraxial rays, sorry. These are all paraxial rays. Okay, then say carefully here. Once again. Is it clear? Okay. I think little dark it is. That's it. Okay. Okay, now see carefully here. See tan alpha is equals to H naught by D. Then see carefully, see from here. See, this is the object distance. That is called a U. Okay, U is the object distance. Okay, object distance here. Okay, now tell me, say from this diagram, what is tan beta? See, tan beta is equal to beta. See, tan beta, see in this triangle. In this triangle, let us take it is nothing but H naught by U. Can I write like that? Okay. Thank you, Dheeraj Ishwar. Okay, now see carefully. See how you will define the magnification. See, the magnification is equals to magnification of a simple microscope. M is equals to, see, the angle made by the instrument by the angle made by the direct. Okay, see the angle made by the image by the angle made by the object with the eye. So here nothing but it is nothing but, see, the beta by alpha. So what is beta here? Beta is nothing but, see, H naught by U by the H naught by D. Okay. See here, if you observe carefully, see both are negative. Both are negative, so that's why I did not wrote here. So therefore I say, can I write and say M is equals to what? 8 is nothing but the D by U. So what the magnification formula for a simple microscope? That is D by U. But see carefully here, the image will form at D here. So therefore say, let us take like this, see U is equals to minus U. Okay, see the V value is minus D. Okay, means here, see, this is the case 1. What is the case 1 here? The image is forming a D. Okay, see here U is equal to minus U, V is equal to minus D. Then see we have 1 by F is equals to 1 by V minus 1 by U. Okay, therefore see 1 by F is equals to, see here what we have here, this is minus 1 by D plus 1 by U. Therefore, what is 1 by U here? See, 1 by U is equal to 1 by F plus 1 by D. Okay, now here see what I will do. It's Sai Siddhartha. Good morning. Okay, here I am rubbing this part. I think you might have copied. Okay. Okay, see carefully here. It's Sai Siddhartha. Good morning. Okay, now see carefully, 1 by U is equal to 1 by F plus 1 by D. See, let us try to substitute here. See, therefore, see what the magnification here. See, the magnification will be D by U, or D multiply. See, 1 by U is what here? 1 by F plus 1 by D. Therefore, see what the magnification here. If I multiply with D, 1 plus D by F. That is the magnification. See, this is the magnification when, see, when is this magnification? See, M is equal to 1 plus D by F. See, when the object, when the image forms at the least distance of distinct division. See, when the image is formed at the least distance of distinct division, then see, the magnification is how much here? 1 plus D by F. Now, see, at the same time, say, for example, see the case 2 here. Okay, I think you might have copied this one. Okay. See, for example, say while you are arranging it, let us say this object is placed at F. If the object is placed at f, then see where the image will form. The image will form at infinity. So therefore here, see once observe carefully, see the case 2. So what is the case 2 here? The image at infinity. Okay, the image is at infinity. So if the image is at infinity, then tell me here, see carefully, what is the u value? The u value is nothing but the minus u. Okay, see carefully, what is the v value here? The v value is at infinity. Therefore, what is the 1 by f here? 1 by f is equals to 1 by v minus 1 by u. See, 1 by f is equals to 1 by infinity minus 1 by u. Okay, minus of minus will be u. Therefore, see u value is nothing but f. Or nothing but say 1 by u is equals to 1 by f. Then here, what is the magnification that time? It is nothing but say, if I substitute here, say d by u, it is nothing but say magnitude at infinity is nothing but the d by f. Okay, so means here when you are going to get the maximum magnification regarding simple microscope, see when the image forms at least distance. Okay, say when the image forms at least distance of distant division, then you will get the maximum magnification. When the image forms at infinity, you will get the less magnification. Okay, see let us try carefully. Let us try carefully one simple problem. Okay, say I am rubbing this part. Okay. See, let us try one simple problem. Okay, come on, take one example, simple thing. See, let us say the focal length of the lens. Okay, see the focal length of the lens is, let us say, the 100 centimeter. Okay, the focal length of the lens is 100 centimeter. Okay, now tell me the maximum and minimum magnification. Okay, find maximum and minimum magnification. One, please try. Say if the focal length of a lens, the focal length of a convex lens in a simple microscope, okay, is 100 centimeter, find the maximum and minimum magnification. Okay, please try this one. Please try, see how much you are going to get. The maximum and minimum magnification. Okay, please try. Yes, very good. Very good. That is nothing but 1.25 you can write. Very good, Dheerajeshwar. Good. Yes, minimum is how much? 0.25. Good, very good. 1 by 4. Good, very good. See carefully, when you are going to get the maximum magnification here, it is nothing but see m max is nothing but 1 plus d by f. Okay, and say the m minimum is nothing but d by f. So therefore, say how much will be this? Here it is nothing but say 1 plus d. What is d? Okay, d value is 25 centimeter. You need, okay, they need not give. You should take it. Say it is nothing but say 25 by 100 means here 1 plus 1 by 4. It is nothing but 5 by 4 or nothing but 1.25. Means a 1.25 times you got the magnification. Yes, good. Good, Umesh. Very good. Now what is the d by f? It is nothing but 100 by 25. Sorry, 25 by 100 means nothing but 1 by 4 or nothing but say 0.25. See, no units for magnification. No units for magnification. Why? Because the magnification will just tell us see how many times it will increase. Okay, are you understanding what I am saying here? Means here in a simple microscope, what we got here, what is the principle of simple microscope? The object is to be placed. Okay, the object is to be placed. Sorry. Okay, the object is to be placed exactly between optic center and focus point. Then you will get a psi print good, so that you will get the magnification. Okay, to get the magnification, it is nothing but a magnifying glass. But see, why we are not using simple microscope? Because it will cause eye strain. Okay, to avoid eye strain here, what we have to do? We need a compound microscope. Very good, Nani Natural. Good name. Okay, now so let us move on to the next one. Okay. Remember, by today evening I'll be keeping the worksheet. Okay, if possible, please try that worksheet. Okay, next week we are going to discuss gravitation. Okay. Okay. Now see, next see carefully here. Next, what we have. See, this is called as compound microscope. See, once if you got the simple microscope, the compound microscope and the other microscopes are very, very easy. Okay. Okay, now see carefully here. So if you look at this compound microscope, okay, see in a compound microscope is what? It is nothing but it's a combination of two lenses. See, one lens we will call it as objective lens, the other lens we will call it as eye lens. See, remember in this case, the eye lens is usually of very, very large focal length and the objective lens is of very, very small focal length. You see carefully, compound microscope, this is the compound microscope if we take. See, this is called an objective lens, which is our short focal length. Okay, this is called, okay, here I'll write. This is called objective lens. Okay, and see there will be eye lens will be there, which is of large focal length to avoid the eye strain. This is of eye lens. Okay, and see carefully, see the, okay, here also see I am using only one ray to represent the diagram, but remember you need two rays to represent the diagram that you can see in the description box later on. Okay, but today evening you can see that. Okay, now see carefully here what we have here. Suppose see, so this is the objective lens. This is F0, this is FE. Remember, FE is greater than F0. Means FE means the focal length of eye lens. F0 means the focal length of objective lens. Okay, see carefully here. Somewhere you can keep the object. It's not an issue where you keep the object. Okay, see wherever you place the object, but remember the image should form. Where the image should form. That's very, very important. See carefully here, the image of this one, see carefully here, where it will form. See, it will form somewhere here. And see, remember, this is the focal length of the focus point of the eyepiece. And see, this is the optic center of the eyepiece. Okay, this is the optic center of the eye lens, the objective lens, the optic center of the eye lens. Okay, means see carefully here, what will happen? You are here, you are seeing it, and see the image will form here. Come on, have you understood anything here? This is the image 2, this is the image 1. Okay, see carefully here what is happening here. Number 1. So here I place the object here. This is image 2, sorry. This is image 2, this is the object. Okay, see carefully here. Here I place the object. Okay, here, due to this object here, due to this objective lens here, what happened? The image formed at I1. Okay, see the image is formed at I1 here. See, this image is object for eye lens here. Okay, this image 1 is the object for eye lens. But see where the image formed here, between the eye, between the, what is this, the focus point of the eyepiece and the optic center. So means what here? So if you forget this one, see if you look at only this, see this is just like a simple microscope here. This is nothing but a simple microscope only here. Okay, are you following what I am saying here? So means here, see what is happening here, see observe here. So this is the U0. Okay, this is the V0. Okay, and see this one is UE. See, please try to understand this this UE, V0 and U0. And see carefully, this one is what here? This one is D. The final image is formed at near point only. But see, try to understand here, what is U0 here? The object distance from objective lens. Okay, objective lens. And what is V0 here? There is a image distance from objective lens. Then what is UE here? UE here. See, it is nothing but the object distance from eye length. Okay, UE is that. Then say sometimes they will also ask another important question. Say what is the length of the compound microscope? This is L. See what is the length of the compound microscope here? The L is nothing but see V0 plus UE. Okay, see the L is nothing but what here? The V0 plus UE. Please remember that. See the length of the compound microscope. See what is the length of the compound microscope here? It is nothing but V0 plus UE. See remember, see especially in HC Verma, see there is one separate chapter there, optical instruments. Okay, if possible, please try to refer that chapter. There are around 30 questions are there. If possible, please try to solve them also. If you are not getting any of the answer, please let me know so that I can explain the next class. Okay, now see carefully. See, are you understanding what I am saying here? In a compound microscope, we got two lenses. One is a short focal length, we call it as objective lens. The another one is a large focal length, we can call it as eye lens. Okay, the object is placed here and the image one will form like an object for the eye lens. And that is nothing but a simple microscope. Why? What is the principle of simple microscope? The object is to be placed between the focus point and optic center. Okay, then how to do this problem here? See carefully here. See, it's a simple one. Here, the magnifying power, okay, magnifying power M is equals to M0 into ME. Means the magnification due to objective lens, and the magnification due to eye lens. Okay, so here it now tell me what is the magnification due to objective lens here. See, it is nothing but V0 by U0. See, this is V0, this is U0. Okay, and see here we can also say what is the magnification due to eye lens here. So here one case will come. See what is the case one here. Let us do the case one. Okay, the final image at near point. Okay, final image at near point here. So means what is the ME here? Say it is nothing but I said it's a simple microscope. So simple microscope means how much? 1 plus D by Fe. That's what we learned here. We learned earlier in simple microscope 1 plus D by Fe. Therefore let us use that one here. Therefore what is the magnification of compound microscope? It is nothing but M0 into ME. Nothing but V0 by U0 multiply 1 plus D by Fe. Okay, so are you following what I am saying here? See, it is nothing but say V0 by U0 1 plus D by Fe. Or if not, see, you can also write on this one, see careful sometimes. See, sometimes it will happen in such a way that suppose see, if I place this object very near to the focal length of the objective lens. Means suppose I am saying here. Okay, see carefully, suppose, see let us say if the UO is almost equal to F0, is almost, not exactly at F0, see almost. Okay, then see carefully, then see what will happen. The V0 will be, you can take it as L. What do you mean by L here? See, L is nothing but, see V0 plus U. Means that time what we do, we will neglect the UE part. Means that you can take it as say U0 equal to F0. See, V0 value is almost equal to L. See, in that case, what is the M value? It is nothing but say L by F0 into 1 plus D by Fe. Okay? Or suppose if they give the U0 value, L by U0 into 1 plus D by Fe. Either way, whatever may be possible. Either. See, this is only possible. But the actual one is this only. And see the case 2 here in this one. What is the case 2 here? Means if the final image at near point, see the final image at infinity, the final image at infinity. If the final image is at infinity, then see what will happen here. So the M infinity is equals to, see it is nothing but D by Fe. So therefore here what you can write is M can be written as See V naught by U naught multiply the D by FE or L by F naught into D by FE. Okay, like that. Either way it is correct. Okay, see, are you following what I am saying here? Means see here, it's a very simple. See, the compound microscope is very simple one. See, in a compound microscope, what we got? We got two lenses, objective lens and eye lens. Okay, and see the image of the objective lens forms the object for the eye lens, and the eye lens is nothing but a simple microscope. See, every time the same thing will happen. Even in a telescope also the same principle. Okay. I hope you understood this one. Okay, I am just rubbing it. Okay, have you understood this? Okay. Okay, then see carefully. Okay, now see, let me explain the another one. Okay, see, let me explain the. Okay, see, I am not saying any problem regarding this because I have already taken more time. Okay, now see, let us quickly say the telescope. Okay, see, what is the telescope here? See, this is another very important. See, now first I am going to discuss. So this is called as astronomical telescope. Okay, astronomical telescope. See, what is this astronomical telescope? So the astronomical telescope is used. Okay, the astronomical telescope is used to see the distant objects like stars, planets, and the other celestial objects. Okay, to see the other celestial objects, you need an astronomical telescope. See, in the astronomical telescope, see here, again we use two lenses. See, one is called as objective lens, the other lens is called as, objective lens, the other lens is called eye lens. But see, in this case here, what we'll do is that, see, the objective lens, focal length is greater than the eye lens here. Why? Because see, you wanted to capture the light from the distant object. Okay, you need to catch the image. Okay, you need to catch that object which is far off distance. So here, see, what will happen. See, suppose if you take this is the principal axis. See, this is the objective lens, the very large focal length. This is the objective lens. Okay, f naught. Okay, and see, this is the eye lens here. Okay, this is the eye lens. See, this is the eye lens. Okay, eye lens also you can also call it as eyepiece. Okay, now see here what will happen. See that, see the object is at very far, means at infinity. Then tell me where the image will form. The image will form definitely at the focal length of the objective lens. See, the image will form definitely at the focal length of the objective lens or not. And see here with this. Okay, let me draw a little bit here. Okay, the focal length of the objective lens, and say the focal length of the eyepiece is here. One you might have understood right now. See here that this is the image 1. See, the image 1 means somewhere here the star, something. Means here, see, the objective lens image is forming here. Okay, and see from here, see, you are seeing through this eye lens. Then see the image will form virtual, erect and magnified image. Virtual, erect and magnified image. See, as suppose you wanted to see the moon will appear inverted, but see, it doesn't matter. So you see the moon inverted or erect, anyhow you are seeing it very bigger one. That doesn't matter. So you are seeing the star again in an inverted order, that doesn't make any sense. But say finally you are seeing or not. Okay, see carefully here. See, first of all, see here is the object. The first image will form at focus point of the eye lens. Focus point of the objective lens. And see carefully, see where the image is formed here, between the focus point of the eyepiece and its optic center P2. This is P1. Okay. Okay, see, are you following what is? So here the final image is formed here. This is the final image. This is I2. See here what you will do is, see, let us call it as alpha. See, let us call it as beta. Okay, same, just like see in the simple microscope what we got, the same model. Let's see, what is that same model? Means it is nothing but, see, the magnifying power is what here? The magnifying power is nothing but the image, see, the angle made by the image by the angle made by the object. Okay, see, once the object, you can see what is this one? This one is F0. This one is F0. Okay, and see what is this one? This one is UE. Okay, see, F0 is what you have, the focal length of objective lens. Focal length of objective lens. Okay, and see what is UE here? There's a object distance. Okay, object distance from eye lens. See, once you here, see in this diagram, see this is P1, this is F0, this is I1. See carefully, what is tan alpha here? The tan alpha is nothing but the height of the object, let us say. The height of the object by this F0. This is minus F0. Oh sorry, this is plus F0 because see this side, this is the incident ray. Okay, then tell this is nothing but alpha. Now tell me what is tan beta? What is tan beta? See H0 by minus UE. See H0 by minus UE. See, let us substitute here. Then see what is beta here? The beta is equals to H0 by minus UE by, see, the H0 by F0. Okay, so therefore see what you can write, say M is equals to minus F0 by UE. That is a magnification. But see carefully here, see what we are doing here. See, we are getting, see, this is the simple microscope formula. Again we got another thing. What is that one? See carefully here what we have. See what is this called? See, case 1 image, the final image at near point. Okay, the final image is at near point. Okay, see if the final image is at near point, then see what will happen here. See carefully, you can write here. See what is this one? See U is equals to minus UE. Okay, V is equals to minus D. Therefore, a 1 by Fe is equals to 1 by V plus 1 by U. Sorry, 1 by V minus 1 by U. So 1 by Fe is equals to what is 1 by V minus 1 by D minus of minus 1 by UE. Therefore, what is 1 by UE? See, it is nothing but see 1 by Fe plus 1 by D. What is 1 by UE? See, can I substitute there? See, M is equals to, see, M is equals to minus F0 by UE, nothing but see minus F0 into, see, 1 by Fe plus 1 by D. Okay. Okay, now see here, let us bring the Fe out. So see what is the magnification then? Say minus F0 by Fe multiply 1 plus Fe by D. Okay. Okay, see, are you following what I am saying here? See, what is the magnification here? See, what is the magnification here? Magnification equal to F0 by Fe into 1 plus Fe by D. Okay, see, are you following what I am saying here? See, the magnification is equals to minus F0 by Fe into 1 plus Fe by D. See, are you following what I am saying here? Okay, see, this is a magnification of the astronomical telescope. And when the image is forming, see the final image is formed at D. So when the final image is formed at D, then we got the magnification like this. Okay, so are you following what I am saying here? So this is called an astronomical telescope. Okay, then see carefully here. See, we have a terrestrial telescope. See, regarding terrestrial telescope, see what we got here. The same thing, everything is same. But only thing is that we will keep there one erecting lens. See, when you keep that erecting lens, then see what will happen. The image will form erect. There's a difference there. Okay, see the same thing I explained in the description box. Once just see that. See, I'll just draw. Okay then. Okay then. See, you can see that one in the description box. Okay, na? Okay, I think I have taken more time. Okay, thank you all for listening to me. Okay, see carefully in the description box. I will be giving you around 20 problems. Okay, please solve those problems. And in the next week, see, I am going to discuss gravitation. Okay, please attend that class. Okay, don't miss the class. Okay, we'll be having lot of fun. Okay, this is Vijayam Physics classes. Okay, thank you for listening to my class. Okay, please see that astronomical telescope and terrestrial telescope, compound microscope and the other devices which I explained in the description box clearly. Okay, bye to all of you. Okay, have a good day, have a great Sunday. Thank you all. Bye to all of you.